Question number 5, with a diagram showing A, B, C, D, E as the points on the diagram, 70 millimeters for AE. Each angle shown inside the diagram is 14 degrees, 36 degrees and 20 degrees respectively. And we are being requested to calculate the length of BC, that's BC. Now, looking at the information given in the diagram ABC, we're only given the angle opposite the side that we're going to be looking for, that is BC. Now, for us to get BC, we need at least one more parameter, which is either AC or AB, so that we can be able to use the trigonometric functions that will assist us to calculate the length of BC. Now, from where we are, we can see AE has been given. That means we can move systemically towards the triangle ABC in order to obtain either AC or AB. But whichever we obtain first will actually be perfect for us. Now, let's see how we can be able to get the length of BC. So now, when looking at this line, it is perpendicular to EC, that the line AD is perpendicular to CE. That means that's another right angle triangle, and this is also a right angle triangle, where 70 millimeters actually represents the hypotenuse. That will be my hypotenuse. And then the ED will be my opposite side when I'm talking about triangle AED or ADE, whichever the matter. Then AD is actually my adjacent side. Adjacent side. When I'm talking about angle 14 degrees. So for me to get AD, I would then have to calculate AD using trigonometric functions. Remember, that's my adjacent and I'm given the hypotenuse. So the relationship between adjacent and hypotenuse, as per our TOR acronym, that would then be adjacent and hypotenuse is a cos relationship. So for me to get my adjacent side, I will use a cos function saying cos 14 degrees will be equal to, cos 14 degrees will be equal to what? My adjacent side over hypotenuse. Adjacent side being AD, or over my hypotenuse side being AE, and that being AD, that's AD. So AD equals 70 millimeter cos 14 degrees. Now we punch that into the calculator. Therefore, our AD will be equals to, it's actually 67.9 millimeters. Now, we're going to do the same for the next line, that is AC. Now, for us to get AC in the triangle ACD, we will notice that what was our adjacent this side still continues to be adjacent as well this side, and this being the opposite side of the 36 degrees, and this becoming the hypotenuse. Therefore, for us to get AC, we would have to use the hypotenuse and the adjacent side again, which is a relationship of cos. In this case now we're using 36 degrees is equals to adjacent side being 67.9, and that is actually AD, over hypotenuse, which is AC, and that's going to be AD has already been found to be 67.9 millimeters over AC. Now with cross multiplication making AC subject of the formula, this is going to become AC is equal to 67.9 millimeters over cos 36. Therefore, AC will be equals to, we punch that into the calculator, 67.9 divided by cos 36 degrees, that being 83.93. In this case I'm going to make it round it off to 2 decimal places just so not to disturb the 83 to becoming 84. All right. Now that's going to be 83.93, which is actually 83.9 in any case. It's 83.9 millimeters. Right. Now that's degrees there at 36 degrees. Now we have our AC being 83.9 millimeters. We put millimeters there as well for consistency. Now we're going to need the opposite side. In this case, remember we said BC is opposite the 20 degrees, and this AB is adjacent the 20 degree angle. For a lack of space, I'm going to erase this part. Hence, we've already written the parameters of the sides. Now, here goes. We're now going to calculate BC. Now, opposite with a relationship of hypotenuse is a sine relationship. So that's going to be sine 20 degrees will be equals to opposite side, that's BC, over hypotenuse side being AC. And that tells us that it's BC over AC, we've just calculated to be 83.9 millimeters. Cross multiplying and making BC subject of the formula, that's going to be BC will be equals to 83.9 millimeters cos of 20 degrees. Therefore, BC will be equal to, punch that into the calculator, cos 20 degrees, that gives me 78.9 millimeters. So BC is actually 78.9 millimeters. So that was quite a catchy one. The system that we use what we have in terms of complete parameters and data to complete the next one. After finding enough information for the next one, we calculate the following line. After that, we now have enough information to give us BC. I hope we understood that one.